Welcome to the video on Chapter 2 segments and real number properties. This is video 2, and this will actually focus on using a ruler. When reading a regular ruler, there are customary units and there are metric units. Customary units are what we use here in America. We measure things using inches, feet, yards, etc. The trick is with this is that if you ever don't have a whole inch, a whole foot, or a whole yard, for example, then we use fractions to represent those parts. Metric units are used in a lot of European countries, millimeters, centimeters, meters, etc. And the key is with these is that you're allowed to use decimals if you ever don't have a whole of those units. Let's take a closer look at the side of the ruler using the customary units with the inch. The whole inches are normally very clearly marked. Anything that's not marked, we have to use our reasoning skills to figure out what the measurements actually are. So this longest black line here, longest measurement that's halfway in between 0, which would be the beginning of the ruler, and 1 inch, is going to be the ½ inch measurement. And then halfway between each of those would be the quarters. So this is 0, 1/4, 1/2, 3/4, 1. So those are the 1/4 inches. And remember that 1/2 can be written as 2/4. Okay, so that's the same measurement. So 1/4, 2/4, 3/4, 2/4 is 1/2. Then in between, like halfway in between each of those fourths are going to be the eighths. So 1/8, then 2/8, then 3/8, then 4/8, and then 5/8. 3/4 is 6/8, and then we have 7/8, and 8/8 would be the 1 whole. So we don't label that as 8/8, just like I'm not going to go back and label this as 2/8. We're going to try to keep it as simple as possible. The last piece that we normally measure in inches is actually not labeled on this ruler, so we're going to have to add it to your paper. So halfway between each of these, also put in a little shorter tick mark, and that measurement represents a 16th. So 1/16, 2/16, 3/16, 5/16. And I'm not skipping those even numbers, but those even numbers can be simplified down to another measurement using another denominator. 11/16, 13/16, 15/16, and then again the 16/16 would be that whole inch. So this is how we measure our inches. We don't go any smaller than that normally when we're actually measuring using a ruler. Now taking a closer look at the centimeter, the metric side of the ruler. These longer, clearly labeled whole centimeters, and then the second longest unlabeled lines would be the half. And we use, again, the decimals to represent the metric units. And it's not that you can't use decimals also with the customary units, they're just not very nice decimals. Okay, eighths ends up in like 0.875 and things like that, when the centimeters and the metric unit is nice tenths, hundredths places. So 0.5, and actually let me go ahead and put a 1.5 here because that's where that is in between the 1 and the 2. And then each of these tick marks down here at the bottom is a tenth. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the lovely thing about how this works is that it's very clearly a decimal increasing really by tenths, because there are 10 millimeters, that's what each of these little tick marks is, represents 1 centimeter. So in green and even the pink there, it's really representing the increments of millimeters. But when you have 5 millimeters, it's the same thing as half of a centimeter. So this would be 1.1, 1.2, 1.3, 1.4, 1.5, and so on. And that's one of the conveniences of the metric system. So just another quick comparison between the two. If you were to measure something out to this second line after the 1, this would be based off of, they don't have the half here, this is the 1/2. So this is 1 and 1/4. I am not using 1.2. I know it is 2 tick marks after the 1, but it's not 1.2. You can use 1.25 because that is what a quarter is, but we generally just say 1¼ inches. Unlike something that might be marked here, 2 tick marks after the whole centimeter is 1.2. Again, that's the convenience behind the metric unit, but customary units, we just have to make sure we're using fractions. Let's go ahead and get into some vocabulary. Measurement consists of the measure, the number, and the unit, so inches, centimeter, etc. Please make sure we are labeling our measurements. Precision refers to the smallest unit of measurement on the tool. So for most rulers in the customary, it would be a 1/16 of an inch, for example. In the metric unit, it would have been a millimeter because that's what each of the tick marks represented. The greatest possible error refers to half of the precision, so half of the shortest unit. Because we are all likely to make mistakes, we're going to start taking the greatest possible error into consideration. And we're going to use that to calculate the percent of error, which is the ratio of the greatest possible error with the measurement itself. So let's take a look at applying those vocabulary words with some examples using both the customary and the metric system. So precision, remember, is the smallest unit. The greatest possible error is half of that smallest unit, and the percent of error is calculated by the GPE, the greatest possible error. So you're going to take the greatest possible error, we will divide it by the actual measurement, and we're going to multiply it by 100 because we do want a percent of error. So let's take a look at 3 inches. So when we are measuring with a ruler, 1/16 of an inch is the smallest unit. It's the smallest part of an inch that we drew on our rulers. The greatest possible error will always be 1/32 of an inch because that's what half of 1/16 is. So when you're measuring things in inches, these numbers will not change. It doesn't matter what you're measuring. I did not mention the 3 at all yet. What matters is that we are measuring in inches, which makes a 1/16 the precision, and the 1/32 the greatest possible error. It is now when I'm going to calculate the percent of error that I take into consideration my actual measurement of 3. So we will take that GPE, which is 1/32, we will divide it by 3 and multiply by 100. So in this example, 1.04% is the percent of error when you're measuring something that you measure as 3 inches long. So looking at the example in the metric unit with centimeters, 15 centimeters is our measurement, but again, that doesn't matter. The precision amount, 1/10 of a centimeter is the smallest unit of measure when we are measuring in centimeters, so 1/10. We could call it a millimeter if we wanted to, but I think we'll just stick it with 0.1 centimeters. And as long as we're consistent, we should be good. So half of 0.1, so we're going to take that 0.1 and divide it by 2. Half of that is going to be 0.05 centimeters. Again, let's just stick with the centimeters for now. If that really confuses you, we can discuss millimeters. But then this is when we finally get to take that 15 centimeters into consideration. We take that GPE of 0.05, we divide it by the actual measurement that we measured. We're pretending here that we measured something 15 centimeters long, multiplying that division by 100 to turn it into a percent, and it's still 0.33%. It's not 33%, it's 1/3 of a percent. It's 0.33%. And that's what your percent error would be if you were measuring something that you feel is 15 centimeters. So again, this precision and the GPE really are going to be the same for everything measured in inches and for everything measured in centimeters. So we can really just start to maybe memorize these values. It's the percent error that changes depending on what you actually measure the item to be. If you are doing this video at home and you have the printed notes and have a ruler, go ahead and do this activity with at least measuring the line. Those of you that are going to be in class, we're going to try to do this one together. This is the only one that requires actually measuring. So just do what you can with it. Follow these instructions, use the examples from before and even the examples after this if you need to try to do it from the line. But you are doing it twice, one measurement in centimeters and one measurement in inches. So this example doesn't have something for you to measure, but it does say that a segment already measures 3.4 centimeters. I've highlighted and boxed in centimeters because that will tell us these two answers. I mentioned earlier, as long as you have centimeters, this will always be the precision, and therefore this will always be the greatest possible error, which is half of that. So these are just numbers you can start to memorize. The percent error comes from using this 0.05, dividing it by this 3.4. So this is what's going to change with every problem depending on the actual measurement. And you multiply by 100 to get the percent. So the percent error is going to be 1.47%. This example says a segment measures 13 feet. Now we've not talked about feet, but feet needs to go into inches. So we multiply that by 12 to get 156 inches. So we calculate the precision is always going to be for an inch, 1/16 of an inch, and half of that will always be the 1/32 as the greatest possible error. So we will take this 1/32 and divide it by 156, multiply it by 100 to turn into a percent. This is where you want to make sure that you take the time to actually practice how this gets entered into your calculator, or you're doing it in a couple different steps, because this is a fraction that's being divided. So in your calculator, that could look a little complicated, but this is the correct rounded answer, 0.02%. So enter this in your calculator, please, and make sure that you're getting this answer on your own. Go ahead and try this one on your own. It says a stick measures 32 inches. Going through the same step, focusing on inches. You can check your answer in a second. Please pause the video and do it on your own first. Another example for you to try on your own. In inches again, 11.9 inches. Calculating the precision, greatest possible error, and the percent error. Please pause the video and try it on your own, and then check your answer. Okay, so this concludes the second video for lesson 2 in chapter 2 about segments and real number properties. I just want to summarize everything that the segment part has to come with the betweenness and figuring out which point is in the middle. And then it also has to do with the measuring on the ruler using the customary and the metric units and precision and greatest percent error, things like that. The real number properties come into play when we were dealing with the algebra. We were solving for x and finding those missing pieces on those segments. So that's a wrap for lesson 2. Of course, if you have any questions, rewatch the video as many times as you need. Otherwise, feel free to reach out. Have a great day.